Welcome to the deep dive. We take fascinating, sometimes really dense source material and, well, we pull out the key insights for you. Today, we're diving into a world where communication reliability isn't just nice, it's critical. Think emergency services, public safety, maybe big industrial sites. These systems, they just have to work. And often at the heart of these networks, you'll find a specific piece of gear. We're pulling back the curtain today on the Motorola Tetra stations, specifically the MTS1.
Yeah, and our source today, it's this really comprehensive manual, right? Installation, config, servicing, the whole 9 yards for this MTS1 from Motorola Solutions back in 2011. Our mission here is to cut through all the technical stuff, the jargon, and give you the essentials. What is this thing? How does it work? What does it take to get it running? And, what keeps it going when things get tough? By the end of this, you should have a much clearer picture of what goes into deploying these base stations, from physically setting them up to the invisible signals keeping everything in sync. We're going to uncover some, honestly, pretty surprising details.
Environmental controls, super precise installation steps, components you probably never thought about.
Exactly. And that's really why this matters. A manual like this, it can look overwhelming, right? Super technical, but we're focusing on the principles, the practical stuff that makes this technology actually function reliably. It's a real look into the demands, the level of precision needed for these communication networks, the ones people rely on. Think of it like seeing the hidden engineering, the dedication to making sure this critical infrastructure just doesn't fail.
Okay, so let's start right there. A base station. What exactly is an MTS1? What's its main job? It sounds pretty central.
It absolutely is. So the MTS1, it's the smallest Tetra station Motorola makes. Its core function is to be the main radio hub in what they call a Tetra IP system. Basically, it's the radio frequency interface, the RF link, connecting the big system infrastructure to all the mobile radios out there. The handsets firefighters or police might carry. You could kind of picture it as a mini, very specialized command center just for radio signals, directing traffic, making sure the comms are clear.
Right, so it's not just one solid block of tech then. I'm guessing it's made up of different parts working together. What are the main pieces inside an MTS1?
That's right, yeah. It's modular. You've got several key components doing specific jobs. There's the RF filter module, the site controller, the base radio that has its own heat sink, which is important, and the power supply unit. And what's really interesting is how each one is engineered for a specific task in that signal chain. Take the RF filter module. It's not just filtering. It's actually quite sophisticated. It has a duplexer inside. Think of that like a traffic cop for radio waves, letting it transmit and receive simultaneously without them colliding.
Yeah.
And then there's a pre-selector too. That's more like noise-canceling headphones specifically tuned to pick out the right signal, even if the airwaves are crowded. Really helps cut down interference. Crucial stuff.
Interference seems like a huge deal here.
Oh, absolutely. Then you have the site controller. That's really the brains of the MTS1. It even has an integrated GPS module inside. And it enables different modes, like BOT1 is just basic startup. Then there's a test application mode, powerful, but you need to be careful. The manual warns about that. And finally, the main site controller application. That's its normal operating mode, handling all the radio traffic.
And the base radio itself.
That's the part that actually delivers the digital radio capabilities. It uses voice compression and something called time division multiplexing, TDM, which is just a clever way to let multiple conversations share one radio channel efficiently. Very reliable.
Wow, okay. Much more going on under the hood than you'd think. So the manual really stresses this point. Before you even touch the equipment, site preparation is everything. It seems like tiny details about the location could make or break the whole system.
They absolutely can. And the insight here isn't just the rules themselves, it's why they exist. Grounding cables properly, needing solar shields in hot places. It's not just red tape. It's like a preemptive strike against everything the real world can throw at it. Weather, noise, even mistakes. It's all about keeping it running when it absolutely has to. So yeah, planning has to be meticulous. Avoid interference, maximize the signal. They even recommend keeping cable runs as short as possible. Less signal loss that way.
Makes sense. What kind of things does a site survey look at?
Oh, everything. The location itself, obviously. How much sun it gets if it's outdoors. Mounting height, power availability, including backup power, that's critical. Where the network connections are, the earth points. That's a long list. And for safety, these are meant for restricted access locations. Only trained people should be working on them. And this is really key. The manual insists all antenna cables must be grounded right where they enter the building.
Yeah.
No exceptions.
Grounding again. Okay. What about environmental stuff? You mentioned sun shields.
Right. If it's at a corrosive place, like near the coast with salt spray, needs proper air filters, extreme cold or heat. Below -10 Celsius or above 40 Celsius, they recommend an optional solar shield to protect it. But what's really impressive is the IP66 rating. That means it's dust-tight and can handle powerful water jets. It's built tough. There's also a stark warning about hazardous voltages inside the power supply unit. Definitely not something for field repair. It needs professional servicing. Even specific rules for railways, like installing it at least 3 meters from the tracks, using shielded cables, it all points to building something incredibly resilient.
Right. So the site's prepped, safety's covered, environment's accounted for. Now we actually bring in the unit. It weighs about 20.5 kilos, so roughly 45 pounds. Not exactly light work, is it? Like moving a small, very expensive appliance.
Yeah, exactly. And you definitely don't want to drop this appliance. The manual warns about a crush hazard. It recommends using proper moving companies or at least a sack trolley with good padding. Save your back. Save the critical comms. Once it's there, you can mount it on a wall, a mast, or a pole. But key thing is, you always need access to the bottom for servicing. Then it's time for connections. Grounding again. Power supply, RF antenna, GPS antenna, and the site link cables connecting it back to the main network. Really, all these physical steps, they're about protecting the system against, well, everything, from lightning down to making sure a connection doesn't wiggle loose.
You keep mentioning grounding. How meticulous are we talking here? Is it just connecting a wire?
Well, it's more involved than that. It's critical for protecting against lightning and power surges. The manual specifies a single-point ground, using a specific type of green or green-yellow wire. And it stresses checking the factory connections too, make sure they're tight. It might seem small, but proper grounding is a fundamental layer of protection. Power supply side, it takes standard AC, but needs its own external fuse and breaker. And the power unit uses what they call a floating DC ground concept for added protection.
Okay. And the antennas, RF and GPS.
Yep, specific connectors for those. DIN 716 for RF, N-type for GPS. Again, surge protection is emphasized. Heavy-duty arresters. Because imagine a lightning strike nearby without protection, it could fry the whole system instantly, taking comms offline when they might be needed most. And for GPS, like we touched on, it needs that clear sky view. It needs to track at least 4 satellites for its initial fix. Usually takes under 5 minutes, the manual says, but could take up to 30 sometimes. It even gives tips for avoiding GPS interference, moving the antenna, using a shield. Surprisingly, it mentions even cardboard and foil might work in some cases.
Cardboard and foil. Wow. That's pragmatic, I guess. Okay, so hardware's in, cables are tight, grounding is solid. Now we need to turn it on, digitally speaking. This sounds like where another level of precision comes in.
It really does. So remember those modes. BOT1, test application, and the main site controller application. That test application mode, the manual, is very clear. Extreme caution needed. Use it wrong, and you could actually damage the hardware permanently. And you need special gear for configuration and testing. A service terminal, specific cables, Tetra signal generators, analyzers, specialized stuff.
So how do you actually check if it's working right? Are there specific commands?
Yeah, absolutely. What's cool is how a simple command can tell you so much. For the site controller, typing status stale is like taking its vital signs. It checks the controller's health, its connection state, the site link status, reveals the system's operational heartbeat, basically. For GPS sync, you've got different configurations. Automatic synchronized config, or ASC, means it can sort of free run using its internal clock for a while if it loses the GPS signal. There's also a forced non-synchronized mode, FNC, but the manual generally advises against it. Lets us start without GPS, but timing accuracy is crucial. Think about it. If the frequency drifts even slightly, calls could drop or get garbled. So it needs that accurate timing, usually from GPS and periodic checks or recalibration.
Makes sense. How do you verify the GPS itself is happy?
There's a command for that too. Status Seri. That checks the site reference interface, the GPS. You look for a status like GPS 3D EPIC-X and see how many satellites it's tracking. It also reports something called PDOP, position dilution of precision. It's basically a measure of how good the GPS signal quality is. For initial setup, it needs to be really low, like under 2.0. For normal operation, below 10.0 is generally okay. It's the system checking its own navigational accuracy, which is vital for timing.
And the base radio part.
That needs configuration too. Setting unique IDs, IP addresses. Then you run through a whole set of station verification procedures, checking software versions and, really critically, verifying the transmitter and receiver performance. Measuring things like bit error rate, BER, and received signal strength, RSSI, making sure the signals are clean and strong.
It sounds incredibly thorough. But even with all that, things can go wrong. Systems need maintenance, troubleshooting. The manual covers that too, right?
Oh yeah, extensively. It's like the field guide for keeping the MTS1 alive. It breaks problems down into categories.
Hmm.
Issues with GPS or the site reference, problems with the site link connection back to the network, or faults with the base radio itself. It lists common alarms too, things like receiver synthesizer lock failures, different DC voltage problems, even issues with its internal clock reference.
How do you diagnose something like a site link fault if it loses connection to the main network?
Well, the basics first, like using ping commands just to see if the IP connection's even there. Then there are more specific checks. StatusCref looks at frame relay fragmentation. Imagine sending data in pieces. This checks if the pieces are arriving correctly. If not, voice could get garbled. And StatusCref dives deeper into voice data issues, checking if audio packets are getting dropped or messed up. It's all about systematically figuring out where the communication chain is broken.
Like digital detective work. What about fixing things, like replacing a whole unit?
That's covered too. Replacing an entire MTS1 is obviously a bigger deal. Could mean the site is off air for about an hour, the manual estimates. Though, if they have a redundant setup, 2 site controllers, a switchover might only cause a couple of minutes of outage. Much better. And then there's security. Loading the cryptographic keys, the keys, that's fascinatingly precise.
Keys. Like encryption keys.
Exactly. These keys are what secure the communication, make sure only authorized radios can talk and listen. The process involves connecting a special device, a key variable loader, or KVL, to the main authentication center, then downloading these keys securely into the site controller and base radio. You can do it locally or sometimes even remotely using GSM. It's a very controlled process to maintain that high level of security.
Okay, fascinating. So beyond how it's installed and configured, what are the sort of the raw specs? How tough is it performance-wise?
The specs really back up the rugged design we've been talking about. The operating temperature range is pretty wide, like make it 40 up to plus 55 degrees Celsius. Storage temps too. And that IP66 rating we mentioned, dust tight, water resistant. Physically, yeah, it's got some size and weight, but it's built to last in potentially harsh spots.
And the radio performance itself?
Key things there are the duplex spacing, the bandwidth, channel spacing, all standardized. Transmit power is adjustable, goes up to 10 watts, which is quite strong, but can be turned down as low as 0.6 watts. And that RF filter module has to meet strict ETSI standards, European regulations. On the receiving end, it's got high sensitivity, meaning it can pick up weak signals and good interference rejection. Plus dual diversity reception, which helps combat fading.
And it meets all the usual compliance standards, I assume.
Oh, yes. WEE for electronic waste, or OHS restricting hazardous substances, RNTTE for radio equipment. Has to tick all those boxes. Which raises that interesting point, doesn't it? How these strict regulations really shape the design. It forces manufacturers to engineer for safety, reliability, and environmental compliance right from the start. It's not just about functionality, it's about building something trustworthy enough for critical applications.
So wrapping this up, what does it all mean for you listening? We've gone through this pretty intricate world of the Motorola MTS1, from its core parts, the really demanding installation, the different operating modes, how you keep it running. It's definitely clear that behind seamless critical communications, there's a huge amount of very detailed, very precise engineering going on.
Absolutely. And maybe the final thought to leave you with is this. Think about how those incredibly specific, sometimes seemingly rigid guidelines in a technical manual like this one, how they all add up. They contribute directly to building a communication network that is truly resilient, truly dependable, the level of detail needing a specific sky view for GPS, the exact torque for screws, the secure key loading, it's all focused on reliability. It enables these systems to do so much more than just basic calls, coordinating emergencies, controlling industrial processes. It ensures that sometimes, quite literally, lives can depend on these systems working flawlessly every single time.